Hello everyone. Welcome to this new session. In our previous two sessions we have discussed about all the introductions related to the control systems, all the mechanical systems and all the two types of analogies for analogous systems, that is FV analogy and FI analogy. From this session we are going to solve many problems which are very interesting. Okay. For this one session I think that this whole session would be this one problem itself, because we need to explain you right about how these kind of problems work. This is the first question, that is we need to draw an equivalent mechanical system and electrical analogous system based on the FV and FI analogical method. That is, FV stands for force voltage analogy, FI means force current analogy, for the given mechanical system. That is this the given mechanical system around it. Okay, so this is the mechanical system, not the equivalent mechanical network, but the mechanical system. So here what we can see, that in this direction force is applied, and when force is applied in this direction, we can see that the displacement is given here. That is, this is one displacement of spring and this is other displacement of spring. So there are two displacements in this given problem, and there are one K spring component, another spring component, along with that another mass component and friction. Okay, so now for the first thing what we need to do is we need to write the equivalent mechanical system, equivalent mechanical network, we can say that. Okay, so how to write it? So the first step we have discussed, right, the steps to involved in solving the problem. First we need to identify the displacements. So which are the two displacements here? x1 of t and x2 of t, right? So if we have two displacements, what we need to do, we need to give them two nodes here. We need to name those nodes as x1 of t and x2 of t, and after that check where these components sit, in which displacement. Okay, so here let's consider first this spring k1. We can see that this k1 is between these two displacements, right? So we can simply write this k1 between these two dots, that is, it is between x1 of t and x2 of t. Okay, and all these components, see, m2, b2, k2, and all of these are due to the displacement x2 of t, because x1 of t it's not connected, right? Yeah, this m2, b2, k2, all these displacements are due to this displacement, that is x2 of t. So what we need to do, we need to connect all these in parallel, that is m2 along with that b2, that is friction, and along with that k2, right? So along with that we need to give this force f of t here, like this. Okay, after giving the name for these two nodes and join it. Okay, this would be a closed path. Okay, so here name this is k1, m2, b2 and k2. So this way we need to write the equivalent mechanical system firstly. Okay, so now the next step is writing the equilibrium equation. So since we have two nodes here at x1 of t and x2 of t, so we need to write two equilibrium equations. First for node 1, first write like this, at node 1. Okay, at node 1, so you can see that at node 1 we have this force. At node 1 we have what are all the components present in at node 1? One is this force and k1 spring. So what we need to write is f of t is equal to k1 into, so we have an equivalent mechanical equation, right? So first write that. So this is that mechanical equation that I was talking about, the basic equation that we have discussed, right? M d square x by dt square plus b dx by dt plus kx. So I'll say why I have written this equation. Okay, so this is the given equilibrium equation. So why I have written it is, so in order to write the equilibrium equations at node 1 and node 2 in this problem, so what we need to do is, so here at this node we have this k1, right? So here k1, and we know that in place of here k we have k into x, that is k K1 into this K1 is between these two displacements, right? That is x1 of t and x2 of t. So what we need to write, since there are two displacements, we need to first consider the first displacement, that is x1 of t minus x2 of t. Okay, whenever there are any component that is spring, mass or friction between any two displacements, we need to write it like this. That is we need to take the difference between those two displacements and write. Since we know that in place of in equilibrium equation we have k into x, so that's why I have written it as k1 into x1 of t minus x2 of t. Okay, so since we have only this force and as well as the spring attached to this node, that is x1 of t, so that's all. We need to end this equilibrium equation for node 1. Okay, so now we have one more node, right, that is x2 of t. For that, let's try to write the equilibrium equation. Okay, so in this x2 of t we can see that since there is no force attached to this node, so we can write that the force here we can write it as 0 is equal to, so the first component, let's consider this m2, write it m2 into, so in place of m we have d square x by dt square, so we can write it as d square, and the displacement here is x2 of t, right, divided by dt square, plus the second component is b2 into, we have here in equilibrium form dx by dt, so d x2 of t by dt, plus one more component is k2 into x2 of t, right. So now we would be thinking that this is the end of the equation. No, so here we can see that this k1 also is attached to this only node, right. So we know that this k1 is corresponding to x1 of t as well as x2 of t, right. So we have, again we need to write k1 because this is attached to this node here also, we can see, right. So k1 into, first write it x2 of t minus x1 of t, because this k1 here is attached between these two nodes, right. Since we are considering this node now, first, so for that case we need to write first x2 of t and we need to subtract x2 of t from x1 of t. Okay, so in this way end this equation here as well. So these are the equilibrium equations for node 1 and node 2. So now the real problem starts, that is, first consider the FV analogy. Okay, at node 1 we need to be writing the equation, that is FV analogy. We know that force is replaced by, okay, so I have created a table for you guys in order to remember. We know that for FV analogy, force is replaced by voltage, M is replaced by L, B by R, K by 1 by C and X by Q, right. Similarly goes for FI analogy. So in order to make a problem simpler, so better you make this table every time by solving the problems. Okay, so first thing we know that F is replaced by V. So in this equation f of t would be replaced by V of t now is equal to K1. So what is K replaced by 1 by C. So K1 would be 1 by C1 into X. X is replaced by Q. So x1 of t would be replaced by q1 of t minus q2 of t. Okay, so now we need to solve this, that is v of t is equal to 1 by c1 into, so we know that generally I is equal to dq by dt, right, but we have only q here. So in order to make this q, what we need to do is take this differentiation to another side. Okay, if we take this differentiation to another side, so this would be equal to integration of I is equal to q. Okay, if we take the differentiation from this side and if we bring it to the other side, it would be equivalent to an integration. Okay, so we can write directly that q1 of t is equal to integration of I1 minus integration of I2. Okay, so the next step is, I will be telling you now. So the next step is we need to be taking the Laplace transform. Okay, so you might be thinking why this concept has come here, why maths has come here. So it is necessary to solve the problem. We need to take the Laplace transform, that is why we are taking this Laplace transform, because this v of t we need to replace it by S domain, that is T domain. In order to replace T domain by S domain, we know that the only method used is Laplace transform. So what we need to do, V of T now will be replaced by V of S, okay, is equal to 1 by C1, and take this integration sign. If we take this integration sign outside, we know that whenever we take the Laplace transform, the integration sign corresponds to 1 by S and the differentiation sign corresponds to S, right? It is simple. You need to be knowing that in order to convert it into the S domain, this is the basic thing, okay? So here what we need to do is, when we take these two integration common outside, we know that integration is equal to 1 by S, so we can directly write it as 1 by C1S, okay, into I1 of S. So we have I1, so it will be replaced by I1 of S minus I2 of S, okay. So this is your required when we solve for FV analogy at node 1, we get this equation, okay. So you can, if you want, you can note it as equation 1. So now this is for node 1. Now at node 2, what we are going to do is, since the force is equal to 0, write it as 0. And now the first thing we have, it is L2, right? L2 is equal to d square since we had M2 here, we know that M is replaced by L. So L2 is equal to M2, when we replace by L2, we get L2 into d square Q2 of t divided by dt square plus R2, right? Since we had B2, so B2 is replaced by R2, and R2 into d into Q2 of t by dt. Since in place of b we have dx by dt, right, and x is equal to q in place of FV analogy, plus 1 by c2, where k is replaced by 1 by c, right? So 1 by c2 into q2 of t plus k1, that is 1 by c1 into q2 of t minus q1 of t, right? Yeah. So now what we need to do is further simplify this, that is L2, and we can split this, right? We can write it as d by dt into dq2 by dt, right? Plus R2 into dq2 by dt plus 1 by c2 into q2 plus 1 by c1 into q2 minus q1. You don't want to write, if you want you can neglect this t, okay, of t, q2 of t. Directly we can write it as q2 or q1. So now we know that dq by dt is equal to I. So this would be L2 into di2. Since we have q2, so di2 by dt plus R2 into dq2 by dt, so R2 into I2 plus 1 by c2. Since we have q2, we know that q, when we take q, it is equal to integration of I2, right? I have told you, right? Plus 1 by c1 into integration of I2 minus integration of I1, okay. So now we need to take Laplace transform again for this node. So that's equal to, since we have 0 here, so 0 into L2 into, we have differentiation, right, d by dt, and I told, right, d by dt is equal to s, right? So we need to write L2 into S plus I2 of S plus R2 into I2 of S again, since we don't have any differentiation sign, so R2 into I2 of S plus 1 by C2, and we have integration, so it corresponds to 1 by S, so 1 by C2S into I2 of S plus 1 by, if we take integration common out, so 1 by C1S into I2 of S minus I1 of S. So this is your equation. So name it as equation 2, okay. So these are the two equations. By using this equation, we are going to build a circuit for FV analogy. That is, now what we need to do is, we need to build the equivalent electrical network, okay, using these two equations, equation 1 and equation 2, okay. So here we know that this is FP analogy. So first thing what we need to do is, first we need to write a voltage source around it, okay, V of t plus minus, okay, since this is FP analogy. And we know that FP analogy, in the last step we have told that it corresponds to loop analysis, that is we need to build loops in this circuit. And another thing we know that we have two currents around here, that is I1 of t and I2 of t. So we are going to have two loops, right? We have two currents, right, I1 and I2 in this question. So it's obvious that we are going to have two loops. So first what we need to do is, see the first equation, 1 by C1 of S into I1 of S minus I2 of S, that is, this is in the S domain. So in order to write the circuit we need to use the T domain, and we know that while seeing this equation we can say that this capacitor C1 is between I1 and I2. That is, we can write it as this capacitor C1, see here properly, C1 is between this loop I1 and I2, okay. Whenever we have this kind of form, that is any component is equal to I1 of S minus I2 of S, that it says that that component is between that two loops, okay. So first we need to write that like this, that is between these two loops write this C1, okay. So this part is completed, that is the capacitor part, this C1 is drawn in the electrical network. So what are the other components left? L2 is left, right, R2 is left, and C2 is left, okay. This C1 is this part is done again, because we know that C1 is between I2 and I1. I have drawn it, so we don't need to draw it again. These three components are left, L2, R2, C2. So here L2 S into, see this full term, that is L2 S into I2 of S. So we can say that this L2 is in the loop I2. So what we need to do, we need to build L2, that is inductor. We know that inductor is represented like this, and name it as L2 into I2 of S, right? Since we have I2 of S, so it means that L2 is in this loop I2, okay. And the second thing is R2 into I2 of S. So again we know that since we have I2 of S here, so R2 is equal to like this. Since why I have written it in series, because we know that in force voltage analogy, the equivalent electrical network, all the components would be in series in each loop, okay. In case of FI analogy it's different, it would be node analysis and it would be in parallel, okay. I'll show you that also. So this 1 by C2 of S, that is 1 by C2 of S into I2 of S. We know that in order to write the taking the Laplace transform and writing it in an electrical circuit, we know that 1 by C corresponds to C only, right? 1 by C is equal to C. So 1 by C2 of S, so this capacitor C is in this loop I2. So build this capacitor here, that is C2, and close this loop. And we have no other components left, so even close, you can even close this loop, okay. And this name it as R2 and C2. So in this way we have built an electrical network. See here. So we can say that this is basically a reverse process. That is, in network analysis, what we are doing, using the equations, we were using the circuit, we were building the equations and solving it, right? So here it's a reverse process. Using the equations, we are going to build the electrical circuit. Okay, yeah. So I've told you, right, they would be giving a mechanical system, write the equivalent analogous system, and at last we need to converting it to an electrical system and analyzing it. So the same thing we have done here also, right? We have, by using mechanical system, we have written the equilibrium equations for all the nodes, node 1 and node 2, and we have used the FV analogy part, and we have built this circuit. Okay. So in the same way, now we are going to build it for FI analogy. Okay. So yeah, let's see how it goes. Okay, so now let's write the equilibrium using the equilibrium equations. Let's write some of the equations for FI analogy as well. Since in the question they have given that we need to build the circuit using both FV and FI analogy. Okay. Yeah. So at node 1 we know that F force is replaced by current, that is F of t would be replaced by I of t, and So the next thing we have is K1. K1 would be replaced by 1 by L1, right? In case of Fi analogy, so you can make a note of it here, Fi, where F is replaced by I, M is replaced by C, B is replaced by 1 by R, K is replaced by 1 by L, X is replaced by phi, that is flux linkage. Okay. So K1, we had K1, right, in the node equilibrium equation. So that is replaced by 1 by L1 into x1 of t. X is replaced by phi, so phi 1 of t minus phi 2 of t. Okay. So now further solve it, that is I of t is equal to 1 by L1 into, and also we know that V is equal to d phi by dt, right? So when we take the differentiation to other side, what would be? Integration of V is equal to phi. Okay. So the same thing here, phi 1 of t would be integration of V1 minus phi 2 of t would be integration of V2. Okay. So now we need to take the Laplace transform again. So in order to change the time domain into S domain, that is I of t would be I of S is equal to 1 by L1 into, you know that in integration, if we take common outside, integration is equal to 1 by S when we take the Laplace transform, 1 by L1 into S into V1 of S minus V2 of S. Okay. So this is your one equation. So you can name it as 1, 2 is done. So equation 3. So this is using for node 1. Now at node 2, similarly, what we need to do? Since force is equal to 0, so it would be 0 here. So M is replaced by C, so we had M2, so it would be C2 into D square X2, so X is replaced by phi, so D square phi 2 of D by dt square, plus B is replaced by 1 by R, so we had B2, so 1 by R2 d phi 2 of t by dt, plus 1 by L2, we had K2, right, so 1 by L2 phi 2 of t, plus 1 by L1, we had K1, so phi 2 of t minus phi 1 of t. Okay. So let's further solve it, that is C2 into dV2 by dt. So I hope you got this, how we got, because we know that if we split this into d by dt of d phi 2 by dt, we know that d phi by dt is equal to v, this is equal to v2, so we get dv2 by dt. Okay, that's all I've written. I've skipped one step, that's it. Plus 1 by r2 into d phi 2 by dt is equal to v2 plus 1 by L2 into integration of, we know that phi is equal to integration of v, so if we have phi 2, so integration of v2 plus 1 by L1 into integration of v2 minus integration of v1. So now again apply the Laplace transform, so this would be 0, C2 into d by dt we have, so that is equal to S, so C2 into S into v2 of S plus 1 by R2 into v2 of S plus 1 by L2, we have integration, so that's equal to 1 by S, so 1 by L2 into S v2 of S plus 1 by L1 of S, take common integration outside, v2 of S minus v1 of S. So this is your required equation. Name it as equation 4. So now using these two equations, we need to build an electrical network for Fi analogy also. Okay. So let's see how this network goes right now. We know that for Fi analogy, all the we need to use the node analysis part. So for that thing, first what we need to do is build two nodes. First what we need to do is mark two nodes here and name it as V1 of t or V1. So V1 and V2. And since we have two voltages, so in the first voltage, first thing what we need to mark is, we know that Fi analogy we have a current source. Okay. In Fi analogy we had voltage source, right? Fi analogy we had current source. First mark that current source, and after that check the equilibrium equation, first one. So here we can see that 1 by L1 of S, that is the component here is L1, and also we have V1 of S minus V2 of S. This means that this component L1 is between V1 and V2. Okay. So the first thing what we need to do is, we have V1 and V2 right here. We need to mark L1 between these two nodes. Okay. So one part is done, that is L1 is fixed to its point. So which one of the components are left right now? C2 is left, R2 is left, and L2 is left. This L1 is done, right? These two equations are repeated, only the V1, V2 are replaced, that's it. So this part is done. Okay. Yeah. So now we know that C2, and we have, along with that we have V2 of S, that is C2 is attached to this node V2, that is mark it as C2 here. Okay. Across this node, that is V2 node. The second part is 1 by R2, that is R2 is it is in the node V2, and we know that in FV analogy what we did in this loop, we have put these components in series, right? But here what we need to do, we should be doing the opposite. In this node we need to put those components in parallel, that is take another branch and name it as R2, and one more component is left, that is L2, right? Take another branch, name it as L2. Okay, and join it like this, name it as L2, V1, V2, and all the components are done. So this is your required electrical network, okay, using FI analogy. So yeah, that's all. So this was the one whole problem here. They have told us to build the circuits for FV analogy and FI analogy. We have built it. This is for FV and this is for FI. Okay, so please go through the video once again and try to understand the problem and try to analyze the problem, and also refer our previous video to understand the concept better. Okay, and then try to do the problem by your own. Okay, so that's all. Thank you. Please like, share, subscribe and share it to a huge number. Okay, thank you.